In math, the word pi, which is spelled pi, refers to a very special number. In fact, it's so special that it gets its own symbol. This Greek letter here is the symbol for the number pi. But if pi is just a number, why don't we write it like that? Why do we need to use a special symbol for it? That's a good question, and I'll get to that in just a minute. But first, let's learn what pi really is by seeing how it relates to a circle. It turns out that pi is really a ratio. Now, if you're not sure what a ratio is, you can watch our video about them. But basically, a ratio is just a relationship between two numbers that's written like a fraction. Pi is the ratio of two different distances on a circle. It's the ratio of the distance around a circle to the distance across a circle. And what do we call those two distances? Yep, the circumference and the diameter. So pi is the relationship of the circumference to the diameter. And as you'll see in a minute, because pi is a ratio, it's the same number for any circle, no matter how big or small. Okay, but what number is it? What's the value of pi? Well, to figure that out, have a look at these two circles, one big and one small. We're going to imagine that our circle's diameters are flexible like a piece of string, and that we can wrap them around the outside edges, circumferences, of the circles. So for each circle, if we start at the top and wrap the diameter around the circumference, we see that one diameter is not enough to go all the way around. So let's get another diameter and keep going where the first diameter stopped. Two diameters still isn't enough to go all the way around. It looks like we're going to need to get a third diameter and keep going. Oh, so close! 3 diameters is almost enough, but it looks like we're going to need just a little bit more to form a full circumference. That little bit more turns out to be about 0.14 diameters. That means that it takes 3.14 diameters to equal 1 circumference for any circle, big or small. So the value of pi is always 3.14. Well, okay, pi is a little more complicated than that. 3.14 is really just pi rounded off to 2 decimal places. And we actually have to round pi off because it's a type of number that's called irrational. An irrational number has decimal digits that never end and never repeat.
Grog confused.
Yes, irrational numbers are confusing. But seeing some more of pi's decimal digits will help you understand what I mean. To be more precise, pi is 3.1415926535897932338, and the decimal digits just keep on going, forever, without repeating. Pretty amazing, huh? But the good news is that saying pi is 3.14 is usually close enough for most math problems, so that's all you really need to memorize. And that's why we use a symbol for pi in equations. We could write pi with just 2 decimal places, or we could write it with 5 decimal places to be more accurate, or we could write it with hundreds of decimal places to be super accurate, or we could just use the symbol to represent the true value, which is infinitely accurate.
The number pi is equal to 3.141592653 and so on and so on. And it represents the ratio of any circle's circumference to its diameter. But why is the symbol pi used? Why not use C or even phi? What about a circle? Why not a picture of a cat? The idea is that any symbol could have been used and the number would still be 3.14159. Well, when Archimedes started to calculate pi by using polygons with more and more sides, he needed a letter to label the number he found. Being Greek, he used peripheria, meaning periphery, or perimetros, meaning perimeter, to describe the circumference of the circle. And just as we would use h to label the height of a tree today, he used the letter pi from perimetros for the number 3.14159. And that is why the symbol pi is used today.
Lately, astronomers have found loads of exoplanets, or planets outside of our solar system. They can find them because when a planet moves in front of its host star, a portion of that star's light is blocked out. Then, as the planet clears, the star's brightness returns to normal. The graph of how we see that light twinkle from Earth is called a light curve, and to figure out how to interpret this light curve, they need to know how big the host star is. So how on Earth do astronomers figure out the area of a star? With the equation for the surface area of a sphere, 4 pi r squared, with r being the star's radius. Once they know how big that star is, they can use that combined with how much its light fluctuated to figure out things like the exoplanet's size and maybe even what's in the atmosphere. Since knowing an exoplanet's size can help scientists guess whether it's habitable or not, pi is kind of essential to our search for planets that might support alien life. So pi is obviously crucial to studying anything that's spherical, like stars, because spheres are just circles swept around in 3 dimensions. And as it happens, the way we calculate the forces of physics has a lot to do with spheres too. Take the electrostatic force, for example, which is the force between 2 electric charges. It's calculated using a handy equation you may have heard of called Coulomb's law. So let's say you have 2 electrons just floating out in the middle of space. Each electron is exerting a force in all directions, so basically its force forms a sphere, and we call that an electric field. But you only see the effect of these fields when they interact, in this case by repelling each other. If you want to calculate how much electrostatic force is driving those electrons apart, you're gonna have to find out how much of each electron's invisible sphere is touching the other. And since we're dealing with spheres again, there is pi. To figure out how much of their electric fields are touching, you need to divide the total force from both electrons by the same formula we use to find the surface area of a star, 4 pi r squared. Now, no discussion of the use of pi in science would be complete without talking about how it was used to describe the universe itself by one Albert, no middle name, Einstein. Einstein published his theory of general relativity a century ago in 1915, which happens to be the last time that Pi Day was 31415. And you know what Einstein's birthday is? Just give me a guess. March 14th. Dude was born on Pi Day. And Einstein's theory of general relativity calls on pi to describe how all forms of momentum and energy can curve space-time. Now, we often talk around here and on SciShow's Space about how huge masses like stars and galaxies can curve space and time with their gravity. But Einstein's theory actually says that just like a ball sitting on a bedsheet, any form of momentum and energy can also curve space-time around it. And the equation that Einstein used to describe that fact uses pi. This equation basically defines the physical universe, so it's got a lot going on in it. But one of its main points is that there's a fixed ratio, a constant, that helps explain the relationship between gravity, momentum, and energy. And pi has to be part of that constant because Einstein was talking about physics in terms of field theory. Just like electrons, each tiny part of an object generates its own gravitational field in every direction, and together they form a spherical field of force around that object. And where there's a sphere, there's pi. For such an important number, it seems sad that pi only gets 1 day a year for official celebrations, and a Pi Day this special won't show up again until 2115. But at practically any moment, you can be sure that somewhere in the world there's a mathematician or scientist using pi for something important.